cover that, don't worry.
Okay.
Yeah, what kind of concept you don't know?
Like ma'am, the chapter only I have some problems, no? Uh,
Mm-hmm.
so I don't know. Let's see if let's go do the questions. If I have doubts, I'll ask them.
Okay, don't worry, we'll go step by step. Okay, so that's why I'm covering very small portion. Actually, we have enough time to cover this, and we'll go each concept. Okay, we'll go to
Okay.
each concept. Okay, so I have taken from here preference relation. Beyond and before that, you don't need much. You don't have much. This is just introduction.
Okay. Ma'am.
Okay,
Okay.
okay. So I have taken that the main points actually. So
Okay. Ma'am.
the preference relation. This is actually about the behind the scene of demand curve. Okay, whenever we are
Okay.
demanding anything, then that is actually the behind scene of the demand curve. Okay,
Okay.
okay. So in this preference based approach, the consumer is making the decision. Okay, how much to purchase, and that depends on his preference. Okay, so whenever you are going to um, denote that, then you are writing this equation. Okay,
Okay.
so if it is like this, then this is known as at least as good as. Okay, remember, at least as good as the next product. Suppose we are writing this x, then you are writing this x, then you are going to read it as x is at least as good as y. Okay, okay. And if it is strict preference, then that means x is preferred to y, therefore x is at least as good as y, but y is not, this symbol is not, okay, not y at least as good as x. Getting my point?
Yes, ma'am. Can you repeat it once again? Like if X is strictly preferred to Y, then X
Hmm.
is at least as good as Y, but Y is not as good as X.
Yes. Okay, so these x and y are elements, these are elements of a bigger set of alternatives. Okay, last time I told you about budget set. Budget set is nothing but the alternative choices, right?
Okay, ma'am.
So out of these alternatives, people choose according to their preference. So x and y are different combinations. Suppose x, one orange and one banana. Okay,
Okay, ma'am.
and y is the combination of one carrot and one apple. Okay, so if someone is preferring the combination x or to y, that means he is actually preferring the combination x is at least as good as y and more. Okay, this means x is at least as good as y, that means x is actually more. But okay, so this means its opposite can't happen. Matlab means y will not be at least as good as x. Okay, getting my point?
Yeah. Ma'am, but you have written Y is like this, not. How do we write like not?
Not is like this, just inverse L.
Okay, okay,
Okay,
okay.
so if x will be at least as good as y and y will be at least as good as x, then this relation is called indifference. Okay, that means the consumer is actually indifferent between x and y. He might go for x or he might go for y. So this is the second one, that the indifference relation, that is written by this symbol. Okay, so whenever it is written, that is read as x is indifferent to y. Okay, this means that x is at least as good as y and y is at least as good as x. Okay, that is why he is indifferent between whichever combination he can purchase. Are you getting my point?
Yes, ma'am.
Okay. So these two relations are preference relations. One is strict preference relation. So remember this actually these notations, because uh, we'll be facing them again and again.
Yes, ma'am.
Okay.
Understood, ma'am.
Okay. So when this preference relation is complete with all the information and it is transitive, then it is known as rational. Okay.
Okay, ma'am.
Individual preferences are assumed to be rational. So for to be rational, actually, it has to have it has to meet two basic assumptions about this preference relation. Those are completeness and transitivity. Am I clear?
Yes, ma'am.
Okay. So in the next step, we are just going to know this completeness and transitivity. So the preference relation that is notated by this one, okay, this symbol, it is rational if it is possessing two properties. Those two properties are completeness. Completeness, last time I told you that if it is complete, it is complete in information. All the informations are within that set. Okay, whether x is as good as y, or y is as good as sorry, x is at least as good as y, or y is at least as good as x, or they are indifferent between them, is actually complete information is available to us. Okay.
To the consumer.
Yeah, to the consumer, correct. So
Okay.
that is known as completeness. Fine.
Okay. Yes, ma'am.
Now we are looking into transitivity. Whenever there is a transitivity coming up, that means suppose there are three combinations in the alternative set of x. Okay, so we are writing it as x, y, z, element of the bigger alternative set, that is capital X. Okay, so these will be considered as transitivity. That relation will be transitive when x is at least as good as y and y is at least as good as z, then x is at least as good as z. Then
Yes,
this
ma'am.
is called transitivity.
Yes,
Okay,
ma'am. Understood this one. Yes, ma'am.
understood?
Yes, ma'am.
Okay. Now we got to know about the preference relation is rational if it is possessing two properties. Okay, that is about preference relation. Now uh, we are just going to the preference relation indirectly, and we want to know if the preference relation is rational, then what is happening to the strictly preference and the indifference. Okay.
Okay, ma'am.
So if the preference relation is rational, then
Ma'am,
what is
this,
happening
this
to,
notation means preference relation. If preference
yes,
relation.
yes, this is preference relation.
Okay.
Okay, and
Okay.
only this relation is called strictly prefer.
Yes, ma'am.
Okay.
Ma'am, but this sign, the preference relation, this sign is also used for this as good as y, right?
Yes, at least as good as, yes,
Okay, so it has two meanings. Like,
yes.
okay, okay, ma'am.
Okay. So when it is written alone, it is just a preference relation. But when it is written in between two variables like x and y and z, then you just have to read it. X is
As,
at least as good as.
okay, ma'am.
Okay. Okay.
Okay,
Now, now we are looking at this condition, that proposition, that if the preference relation is actually rational, then the strict preference is actually irreflexive and transitive. Okay.
ma'am. E-reflexive, what is it, ma'am? I forgot.
Yes. Reflexive, reflexive is x is at least as good as x, correct?
Yes, ma'am. Both the, okay,
But x cannot be preferred to x, right? So
right.
this this cannot happen. So this is called irreflexive.
Okay.
sorry, irreflective. Okay.
Okay.
So if it is strictly preferred relation, if it is strictly preferred, then this relation is actually irreflexive for that variable. Okay. So
Okay,
if
ma'am.
it is x, then x cannot be strictly preferred over itself, right?
Okay, right, right.
Okay. So and it is transitive. So if and it will be transitive. That means if x
I
is
I
got
understood
it,
that point. Yes, ma'am.
yeah, then x is strictly preferred to g. Okay. Now, if this preference relation is rational, then what is happening to the indifference relation? Correct?
Yes, ma'am.
So in indifference relation, what will happen is that will become reflexive. Okay,
Okay.
this will
Okay.
become reflexive. That means x will be as good as, or in x is indifference to x to itself. Correct? So this is the reflexive.
Okay.
But strictly preferred, in strictly preferred case, it will not be reflective. Correct?
Yes, yes.
Okay. And for all x, x will be indifferent for its all value. Then it will be transitive. So if x is indifferent to y and y is indifferent to j, then x is indifferent to g. Okay.
Okay, ma'am.
And then symmetric. So symmetric means if x is uh, indifferent to y, then y is also indifferent to x. Okay.
Okay, ma'am. Okay, ma'am.
Getting it? Any doubt?
Yes. Got it.
Okay. Next is the third one is that if preference relation is rational, then x if x is strictly preferred to or y and y is at least as good as z, then x will be strictly preferred to g. Getting it?
Okay, ma'am.
Okay. Now these are the definitions, and we got three propositions. Okay. These
Proposition
actually
means like these are assumptions. What is
no, no. It is just expanding the preference relation.
okay,
Just
ma'am.
expanding the condition for the preference relation. Okay.
Okay. Yeah.
We are going to prove them actually. We will be solving this question from the book itself.
So we
Okay.
can do like we can do proposition one, then we can do the question so that I'll understand that.
Yeah, we'll be coming back to that. Okay.
Yeah. Okay.
Okay. Just you want to go like that, correct?
So like if we learn something, we can do a question of that. Then it will be simultaneously I'll be learning also. No?
Okay. So let's go for this question then. So there is the property. This is the first question. So we have to prove property 3 of proposition 1.b.1. Okay.
Mm.
1.b.1 and proposition this property 3. So let's see this one. Okay. Just that means if x is preferred to y and y is at least as good as z, preferred to z. Okay.
Yes, ma'am. Okay, ma'am.
Okay. So we are going to prove this one.
Okay, ma'am.
Okay. Let me erase this part. Write it. Okay. They're telling us to prove this one. X is strictly preferred to z. Correct.
Yes, ma'am.
So let's go the opposite way. That suppose g is actually strictly sorry, g is at least as good as x. Okay, we are going to prove. Then hello,
Yes, ma'am. Yes, I'm hearing, ma'am. Ma'am, but this
yeah,
is we are assuming this.
this part,
Yes, ma'am. Z, or we have to prove
yes,
this.
yeah, we have to prove this one. Correct. The
Okay.
question is to prove this part.
Okay.
So we are going to prove it. So to prove it, let's suppose G is preferred over X. G is at least as good as X.
Okay.
So then if G is at least as good as X, then we already have Y is as good as G, correct?
Yes.
At least as good as G. So from these two, you can say that Y is at least as good as X, correct?
Yes, ma'am.
But if this is the case, Y is at least as good as X, but we have already given X is preferred to Y, correct?
Yeah.
So if X is preferred to Y, that means if this means X is preferred to Y, this implies that X is actually at least as good as Y, but not Y at least as good as X, correct?
Yes, ma'am.
So since this cannot happen, this will not be happening because of the this condition, correct?
Yes,
Sorry,
ma'am.
this condition. So oh, that is why the opposite will happen, whatever they have given. So if X is preferred to Y and Y is at least as good as G, then X is preferred to G. Proved?
Okay. Okay, ma'am.
Done?
Yes, ma'am.
Understood?
Yes, ma'am.
Okay. Then question number 2 is also related to that property 1 and 2 we have to prove. Okay. So what are those property 1 and 2? So property 1 is that the strict preference is both irreflexive and transitive. Okay.
Okay.
So have you written this answer? I'm going to erase it. Okay.
Yes, ma'am. No, okay, ma'am. 1 second. 1 second. Just
Mhm.
last part.
Okay.
Okay, ma'am. Okay, ma'am.
Okay. Okay. So in the first part they are telling that it will be irreflexive. Okay.
Okay, ma'am.
Okay. So preference relation is rational when it is complete, correct?
Yes, ma'am.
Okay. So when it is complete, you are having X will be uh, at least as good as X, right?
Yes, ma'am. Yes, ma'am.
For every X that belongs to the bigger set X, capital X, right?
Yeah.
But will there be some X? I'm asking you, will there be any X that will be preferred over itself?
No.
No, right? When X is element of capital X, the bigger set, right? So that means this is irreflexive, already proved.
Yes.
Okay. Okay. Now, uh, then the transitive part we have already proved from this one, correct?
Yes, ma'am.
So you have got this part 1 solved.
Okay, ma'am.
Done.
Yes, ma'am.
Okay. So your property 1 is this property is solved. Now the second question is property 2. Okay. So what is the property 2 actually? That the indifference relation is actually reflexive and transitive and symmetric. Okay.
Okay.
Okay. So here, let me erase this. Okay. So indifference relation, that means for every X that is the element of capital X actually, so your X will be indifferent to x, correct?
Yes.
So that is reflexive.
Yeah, yeah.
Okay. And suppose there is x and that is indifferent to y and y is indifferent to z. Okay. So this
Okay.
means x is at least as good as y is at least as good as z, and this also means that y is at least as good as x and z is at least as good as y. Getting my point?
Yes, ma'am.
So if this is the case, that means x is indifferent to y and g is indifferent to y is indifferent to g, correct?
Yeah, ma'am.
So since x is indifferent to y is indifferent to g, that means x is also indifferent to g, correct?
Okay, ma'am.
So you can see that they are transitive. Okay.
Yes, ma'am.
Okay. Now you can also see from here, if x is at least as good as y and y is at least as good as x, that means they are indifferent, right? So
Yeah.
whether it is x is indifferent to y or y is indifferent to x, that gives you the same result, right?
Yes.
So it means that they are symmetric.
Okay.
So your this proposition is also proved. Okay,
Okay, ma'am.
done.
Yes, ma'am.
Okay, so we just had this question. Okay, then we'll go for the next part.
Okay, ma'am.
Next part is our utility function. That after this they are jumping to utility function in this book. You can see. Okay, we have
Mm.
covered this page. Then utility function. Okay, so
Okay, ma'am.
I'm not leaving anything from this book.
Yeah, ma'am. Yeah.
So utility function, I told you in the last class that it is actually assigning a numerical value to each element in X. Okay. So whatever the choices will
Budget
be,
set, no, ma'am.
yes, please.
X by X, you mean budget set?
This capital X,
Budget set, no, that is budget set,
yes, yes,
right?
set of alternatives. Yeah, that's budget set.
Okay, ma'am.
Okay. So ultimately, the consumer will go for that utility bundle, that bundle actually, not utility bundle, that bundle which is providing its more utility, correct?
Yes.
So when they will be putting the numerical value in utility function, then only he can know which bundle is giving him greater satisfaction. Okay.
Okay, ma'am.
Okay. So this is the definition I have taken here from this book. Okay. So this is the utility function that is representing preference relation. If for all x and y, that's element of x is at least as good as y, if utility of x is actually greater than or equal to utility of y. Okay.
Can you repeat this? Like, if X is equally likely to Y, then utility like that only, no?
Sorry.
Ma'am, can you repeat this point? I didn't get that.
Okay. Yes. So what is this? This is x is at least as good as y, correct?
Yeah. Yes, ma'am.
Okay. There, this is if and only if. This is if and only if. Okay. Utility x, that is utility of x, is greater than or equal to the utility that is derived from this utility function of y.
Okay.
Okay. Is that
Okay.
clear?
Yes, ma'am.
Okay. Then there is this real number set. You know about real number set, right?
Yes, ma'am. Ma'am, real number set, real number I know, ma'am, set as in,
This is just mathematical. They are writing that it's a number actually. It's a real number. So that's why
okay,
they are writing this function.
okay, ma'am.
Okay. Any question?
No, ma'am.
Okay. So any strictly increasing function f that is real number set. So this is a utility function Vx. This is a utility function, and this is actually derived. Its original function is original utility function is u of x. Okay, so
Okay,
ux is a function. Okay, and it has another function over this. That means, suppose you are having something like a plus b. Okay, so this is suppose a function. Okay, and now a plus b whole square. So this is a function, correct? So
yeah.
this is like Vx, and this Vx actually is derived from this function. Okay.
So there are two functions here,
Yes.
and like I didn't understand. So utility function is getting transformed.
Yes, exactly. So
Oh,
this original utility function is actually u of x. That utility function is transformed. Maybe something multiplied, something divided, something like that. Okay. So this is a transformed version of original utility function. Am I clear?
okay, ma'am. Okay.
Okay.
Then why we have to transfer, or like why is this done? Like,
Some it depends on their preference actually.
okay, okay,
Okay. So
okay,
earlier maybe they were consuming 1 unit, then now they might be using 4 times because their family member is more.
okay, okay,
Okay.
okay,
Underlying preference might remain the same, but that quantity might be changing. Okay.
okay,
So f of ux, that is the new utility function, is actually representing the same preference as before. Okay. Okay.
okay.
Okay. Then next is, what is strictly increasing function?
It increases no matter like it does not have any bend. It goes on increasing.
It means if the x value is increasing, then the y value is increasing.
Okay, they are proportional.
Yes, yes. Not proportionately. You cannot say they are proportionately, because if they are proportionately, then there is some relation between them. If the x value changes, then the y value is changing, and they are both increasing. So that is strictly increasing function.
Okay,
Okay. So if you are consuming more goods than before, then you must be having higher utility, right?
yes.
So that's why if your consumption is increasing, then your utility is also increasing. So it is a strictly increasing function.
Okay, ma'am.
Okay.
Okay,
Okay. So let's see this definition. So that was there. We studied that utility function represents preference relation if for all x, y element of capital X. So this is x is at least as good as y if and only if utility derived from x or utility function of x is greater than utility function of y. So when you are talking about utility
now
function, remember,
when
yes,
we say x is as good as y, like it can be better than y, but x cannot be less than y. That's it, no?
please come again.
Ma'am, when we say x is as good as y, means x is better than y
Mhm.
or can be equal to y, but not less than y, right?
Exactly, exactly.
Okay,
Okay,
okay, ma'am. Okay,
okay. So the proposition related to this utility function. Okay.
okay.
So what is the proposition actually? The proposition is that a preference relation can be represented by a utility function only if it's rational. Okay.
Okay.
So you know that when it is rational, when a preference relation is rational.
Yes, ma'am. We had gone through the points, ma'am.
Yes. So what are those points?
Just check. Ma'am, irreflexive, completed.
Completeness and transitivity. A
Okay.
preference relation will be rational when it is having two properties, correct?
Yes, ma'am.
Completeness and transitivity. Okay.
Okay. Okay.
So the question, here it is that telling that preference relation can be represented by a utility function only if it's rational. So we are going to prove it. Okay. We are
Okay.
going to prove it, and the proof is that the preference relation is rational when it has two properties, that is completeness and transitivity. Okay, and we are looking into the completeness. So if the utility function, that is utility function, is actually a real valued function, correct?
Yes.
Why it is a real valued function?
It takes on. It can take on any real number.
Exactly. So that is a real valued function that is defined on x. It is such that whatever the variable that in the set x, then you will be having the complete information. That is, utility of x will be either greater than or equal to utility of y, or utility function of y may be greater than or equal to utility derived from the x, correct?
Yes, ma'am.
Okay, so either of it will be there, and since you are having one utility function that is representing preference relation, that implies that x will be at least as good as y, or y will be at least as good as I, correct?
Okay, ma'am.
So since this will be there, that means this preference relation will be complete, right?
Yes, ma'am.
Okay, so this property is already done. Now we are looking into the transitivity. So in the transitivity, your x is actually maybe at least as good as y, and y is at least as good as z. So since utility function represents the preference relation, you might be having utility of x will be greater than utility from the y, and utility of y will be greater than or equal to utility of z, correct?
Yes, ma'am.
So since therefore you will be having utility of x will be greater than or equal to utility of j, and since utility function represents your preference relation, that implies that the value x will be sorry, the combination x will be at least as good as z. Okay,
Okay.
so therefore your transitivity condition is also satisfied. Okay,
Okay.
so you have got completeness and transitivity. So now you can say that okay, this is proved. Am I clear?
Yes, ma'am.
Any question?
No, ma'am, not till now.
Okay, understood.
Yes, ma'am.
Okay, makes sense, correct?
Yes, ma'am. I had to revise, but it makes sense now, ma'am. I just have to study it once more. I got it.
Okay. Okay, so let's now you have solved this one, you have solved this one. Let solve this one, because this is related to utility function. Okay,
Okay.
so this question is that this function is real valued and it is strictly increasing function. Okay, and the prefer this it's representing the preference relation, and then sorry, this u is actually one utility function that is representing one preference relation. Then this function v, that is a transformed version of the original utility function, is also a utility function that is representing preference relation. Okay, so you have to show it.
Okay, ma'am.
Okay. So to prove this, let's write
Uh,
it down here. So suppose X is element of capital X and Y is element of capital X, and capital X is the set of alternatives. Okay, and your utility function is actually giving you the preference relation, correct?
yes, ma'am.
So X will be at least as good as Y when utility from the X will be greater than or equal to utility from Y, correct?
Yes, ma'am.
And here your F is actually strictly increasing. Okay,
Okay, ma'am.
so if it is strictly increasing, that means utility from X will be greater than utility from Y will be when only if this Vx, this new utility function, will be greater than equal to the another new utility function from Y. Okay.
Okay.
Okay. So here we can use this part that V of X will be greater than V of Y when utility of X will be greater than or equal to utility of Y.
Okay.
Okay. So this implies that your X is actually strictly preferred, sorry, X is at least as good as Y. Okay. So when it is telling that X is at least as good as Y, that means it is representing one function, that is preference relation. Okay,
Okay, ma'am.
clear?
Yes, ma'am.
Okay. So question number 4, this part. This
Yes,
is uh,
ma'am.
this is a rational preference relation, and we have to show that utility ux and equal to u of y, that implies x is indifferent to y, and if u of x is greater than u of y, that implies x is preferred over y, preferred to y. Okay,
Okay, ma'am.
then this means that this utility is a function representing preference relation. Okay, okay, okay. Any problem?
No, ma'am, not no. Ma'am, can you will you share this recording with me? Like, can you share
Yeah,
it?
it will be, yes, yes, it will be there.
Okay.
I'll share this. It will automatically go to your
Okay. Okay.
account. Okay. So u of x implies is equal to u of y. Suppose suppose that x is at least as good as y. Okay.
It is indifferent to I know, ma'am. That
We are coming to that. We are coming to that. So x is at least as good as y, and y is at least as good as x. So in this case, you are having x is indifferent to y. Correct?
yeah.
So, and if this is the case, then u of x will be equal to u of y, correct?
Yes, ma'am.
Okay. But uh, if this is not the case, that means if y is not as good as x, then what will happen? That x will be greater than y. Sorry, x will be preferred to y, correct?
But yes, ma'am.
Okay. And
Yes,
in
ma'am.
this case, you will be having u of x will be greater than u of y. Am I clear?
Yes, ma'am.
Okay. So if x is at least as good as y, in this case, your u of x will be greater than equal to u of y. Okay. It
Okay,
can
ma'am.
be any case. It can be greater than or equal to. Okay.
Okay, ma'am.
Okay. So let's consider another situation where you'll be having your starting point is this one. Okay, your starting point is this one, that u of x is actually greater than equal to u of y. Okay.
Yes.
Along with this, if you are having u of x is equal to u of y, okay,
Okay, ma'am.
in this case your x will be equal indifferent to y, correct?
Yes, ma'am.
So in this case x will be indifferent to y, since it is at least as good as y. That means your x is actually at least as good as y. Getting it?
Yes, ma'am.
Okay, right. But if on the contrary you are having u of x is greater than u of y,
Yes.
okay,
Yeah.
greater than, not equal to, only greater than, that means x will be preferred over y.
Okay.
Okay, and if x is preferred over y, that means x is at least as good as y, but not y at least good as x, correct?
Yes, ma'am.
So if your utility of x is greater than equal to utility of y, then uh, you are getting x is at least as good as y. So if this is the case and you are reaching to this case, then that means it is actually representing one preference relation.
Okay,
Okay.
ma'am. Okay.
Uh, you are having any doubts?
No, ma'am, not till now, ma'am.
Okay. So for today's class, we studied about preference relations. In preference
Some
relation, yes, please.
ma'am,
Hello.
I had some. Ma'am, can you hear me?
Yes, yes, please continue.
Ma'am, actually, I had some doubts in statistics also. Ma'am, I had doubt in one question.
Statistics.
Can we do that? Like, I don't know, like, if you can do that question because it seems a little difficult. I thought that we can divide 15 minutes for that statistics also, if you are
Uh,
okay.
okay, well, send me the question. If we have
Yes,
time,
ma'am.
then we'll proceed.
Yeah, ma'am. Miss, okay, I'll send it, ma'am. 2 minutes.